Alright folks, couple videos for this Friday, get you going on the weekend here, and we'll jump back into things starting on Monday. So when we left lecture on Monday of this past week, or the current week I should say, we were working through general circulation, and there were just a few slides towards the end that we're going to work through here relatively quickly, and that'll set us up well as we get into forces and force balances next week. And so we ended class with looking at our ocean currents. This is going to be something that we revisit on occasion because it'll have importance to any number of smaller scale features, things such as hurricanes or even mid-latitude cyclones. And so again, the idea that we were talking about here with our subtropical highs, those semi-permanent features that are located somewhere in the neighborhood of 30 degrees north and 30 degrees south, we can see that rotation, this clockwise flow in the northern hemisphere around your high, and a counterclockwise flow around your high in the southern hemisphere. We're going to get into why the flow is opposite within the two hemispheres sometime next week as well. But again, this is going to be pretty critical in driving some of our circulations. And so if we tab forward, you can see again with that Gulf Stream, for instance, here we got the coast of North Carolina, Maryland, New Jersey working our way up, and you can see that we get these currents, and they're pretty complex situations. The warmer colors are going to simply be warmer water temperatures, and so we have temperatures here 25 degrees Celsius, which is upper 70s. Not bath water, but definitely warm for this northerly of a latitude, and that's because of that Gulf Stream current helping to bring some of the warmer waters to higher latitudes. And so we got a lot going on this slide, so if you are taking notes, which I would absolutely encourage you to do as you're going through this, it'll help you to understand the material better. We're going to talk a little bit about a couple of features and this idea of what's known as teleconnections, which you can maybe see at the bottom of the slide if you're scanning quickly. And so the two main teleconnections, or really one connection that we just break into separate parts, is El Nino and La Nina, or El Nino Southern Oscillation, which is the acronym ENSO that you see at the top of this slide. Years ago, if you were say alive in the late 90s, which, well, most of you sure don't remember, there would have been a lot of chatter around about the big El Nino that was affecting areas such as the United States. When in reality, the El Nino is going on across the Pacific Ocean, the South Pacific. Here you actually have what's known as these teleconnections that are affecting weather in other parts of the world. And so El Nino, even though it can have impacts on weather, say around Valparaiso, is actually related to abnormally warm waters happening down off of the coast of Peru in the Pacific Ocean. Interestingly enough, El Nino was first found. It was related to bird droppings, or guano. Kind of an odd fact of the day, and it's because there was found to be issues with grabbing this byproduct, shall we say, for fertilizer and other needs, and then the anchovy industry, which was heavily affected by atypical water temperatures, and a lot of fishermen were reliant on this industry, and therefore El Nino was something that we picked up. Stands for the Christ child, and you can look up a lot about El Nino as well. Its counterpart, La Nina, is simply a reversal. Abnormally cold waters off of coastal Peru. And so this may seem like a pretty big jump looking at water temperatures off of Peru, but these are going to be things that are still tied in heavily to our global or general circulation. And so we often refer to El Nino and La Nina as ENSO, El Nino Southern Oscillation. And so we have an island in the Pacific, Tahiti, Darwin, Australia, cities that are separated, or I should say locations that are separate by large geographical distances. But what we'll find is that the highs and lows would reverse themselves, and this is going to be pretty critical as we look at some upcoming slides here on what's known as the Walker circulation. Again, we're still looking at circulations, large-scale features that are happening across the world. And so when we refer to this teleconnection, the definition, weather in one part of the world affects weather in a geographically separated part of the world. This is, again, your idea that we can have this warm or cold water off the coast of Peru and ultimately influence weather across the west coast of the United States. We will show some tie-ins to areas across the southern United States and even some small-scale changes to things across the Midwest. And so these are important because we can predict El Ninos and La Ninas relatively well, and the signal is long-lasting and can help us to make some of our longer-term predictions for above and below normal relative to long-term climate. And so there's a lot going on this slide, so I do encourage you, if need be, to pause and look at things, and we will reinvestigate El Nino and La Nina on occasion. And so on the last slide, I referred to this idea of the Walker circulation. The Walker circulation is not completely unlike things such as your Hadley cell and your Ferrel cell, but here you can see it is a circulation that is happening at the equator. So instead of starting at the equator and working up towards the poles, here we have a circulation that's occurring near the equator. And so in non-El Nino conditions, cold water off the South American coastline, this cold water is dense. You end up resulting in a high pressure sinking air in this general part of the world, or this part of the ocean. Trade winds are strong. That's going to cause this convergence, and this convergence is going to feed into this low pressure out towards Indonesia, what we refer to as the maritime continent, and result in rising motion and a lot of thunderstorms and wet conditions across this part of the world. And so the circulation effectively goes from east to west near the surface, rises here near Indonesia, reverses itself in the higher portions of the troposphere before sinking across the eastern equatorial Pacific. You can see a couple other terms here, such as the thermocline, where we go from warm water to cold water. And during non-El Nino conditions, the thermocline is pretty close to the surface. It's really chilly, not far down below the ocean surface. In El Nino conditions, we warm the water, as we just said on the last slide. And so your atmospheric pressure, because of this warm water, less dense, is going to lead to rising motions, going to lead towards anomalously, in other words, different than the long-term mean, low pressure. And so you can start to see that we effectively reverse this Walker circulation. Wetter, warmer conditions in the eastern equatorial Pacific. Help if I don't click my mouse button. The beauty of trying to work with slides and having them recorded. And so here you can see again we have anomalously wet and warm conditions here and anomalously dry. This can be very significant towards a number of industries. And so we also experience upwelling in some instances where this cold water comes up from the below, and during El Nino we suppress that upwelling. We keep the water near the surface quite warm. And so this can be pretty critical towards a number of other features, such as the jet stream that evolves out over the Pacific Ocean. How do we measure El Nino Southern Oscillation? We simply look at a small rectangle over the equatorial Pacific from 5 degrees south to north, about 50 degrees of longitude, and that's not all that important. But what we're ultimately doing is looking at what's happening in terms of warmth and cold. And so you can see that we have periods with strong El Ninos here. For instance, this 97-98 is the one I referenced earlier. There was basically every news segment would start off with El Nino and what was happening in California, because we were having an anomalously strong jet stream and therefore a lot more precipitation and strong mid-latitude cyclones happening across that part of the world. Relatively calm in recent years, but we did have a strong El Nino in 2015 and 16. And we've also had a handful of strong La Niñas, or the cold side of the event. We'll wrap this up with the idea that there are other oscillations. El Nino Southern Oscillation is far from the only oscillation. And in fairness, I list a few here, and these are far from the only oscillations. Is this the critical aspect of Met 103? No, it's not. But it's still interesting stuff. And what's important about oscillations is that our understanding and the fact that they reverse relatively slowly. We don't, for instance, evolve from El Nino to La Nina in a week. It's a very slowly evolving process, as are many of these, and these processes that evolve more slowly are inherently going to be more predictable and help us with some of our longer range forecasts. So here with the Arctic Oscillation, you can see we just simply have a positive phase and a negative phase. What does this translate to? We can get mild conditions in winter over the northeastern United States versus a cold pattern during the negative cold phase. Significant differences in the storm track across areas such as Europe. And so these can affect mid-latitude cyclone patterns, overall whether or not we see more rain or snow, and ultimately whether or not you get some areas of the Northeast that get blasted by a number of blizzards over the course of a winter. And so we do have this spin up here, this strong wind, lower pressure, and so you've probably heard in recent years of the polar vortex. We don't go into a lot of detail about the polar vortex, but suffice it to say that although the news doesn't necessarily make it as clear as it should be, there is always a polar vortex. It's just some years it becomes a little stronger and dips into some areas such as the Midwest, and therefore gets a lot of buzz when the weather is particularly cold. I encourage you, if you find this interesting, to take a little time to read about other ones, such as the North Atlantic Oscillation or the Pacific Decadal Oscillation in your book. Again, a number of these oscillations that people that are trying to do climate predictions or even simply longer term 2, 4, 8-week forecasts of above and below normal conditions are going to rely on our knowledge of these oscillations and how they evolve in order to have some accurate predictions. And so, as I promised, this would be a relatively short session. We'll make one more video to kind of set us up for pressure going into next week. That's all for now.